Now coming back to the point of time scaling, the time scaling maps the input signal x to the output signal y as given by yt equal to xat. Okay, what is this? Time scaling means if you multiply the time with a is a non-zero real number. Okay, if a is greater than 1, signal is compressed same as previous that we have seen before. The compressed, the expanded, if it is equal to 1, it will be neither expanded nor compressed, it will remain same. If it is less than 0, the signal also a time reversed, same in the previous thing. In previous we have seen the three things: the time reversal, the expansion, the expansion, also the compression. All things are related to this. Okay, that is also known as time scaling. Now you can see here if it's xt, if it is x2t, that will be compressed. If it's t by 2, that is expanded. If it is minus t, that is totally reversed. Okay, totally reversed. That's opposite to each other, these two things. Okay, so time scaling is quite that we have studied before, the three parts: the dilation, the reflection, the the expansion, the compression. All the things are similar to each other. Now, the combined time and scaling and time shifting. So if it is at minus b, that means this thing is scaling, and minus b plus b, these kind of things are shifting. So that is the combined thing. So how can you deal with it? That is the example. How can you deal with it? Okay, that is pt xt minus 1, just shift by 1, and then time scale by 2. Okay, just like this, that is given xt. That is, you have to find x 2t minus 1. How can you draw it? First of all, you have to shift it a pt minus 1. That means t minus 1 means that starts from minus 1, that will start from now minus 2. Sorry, that's minus 2 now, that will be start from minus 1. Shifting, that shifts here, right shift. So you can see here that is it is very interesting. Minus 2, minus 1, 1 and 2. First of all, you shift it by t minus 1. So minus 1, that is 1. That means the same thing that starts from here, goes through here and goes down here. 1, 2, 3. You can see 1. Just one point shift. 1 here, again here, again in this position. So you can get this kind of things. Then p2t. 2t means scale by 2. Why you can scale by 2? You can get the thing. Scale by 2. Just take the half of the time. If it is minus 1, so that will be minus half. Just compress again. 1 should have to be half compressed. 2 should have to be 1 that compressed. Just like this. So if you use these two things, two tools, you can get this. Again, you can take another thing too. If you take time scale by 2 and then time shift by half, you can get the similar thing. Okay. So I will strictly suggest you to follow this. It is pretty much easier process of the combination of time scaling and time shifting, how you could calculate it. Then the below this thing. Okay, here they scale first of all, that means they compress, then they shift it by half. Okay. So if you tell me why it is half, there is another action, another thing that you have to prove it to be 2t minus 1. So just follow this. That is pretty much easier. First shift, then scale, can get your results. clearly. Now amplitude scaling. What is amplitude scaling? Here you can see the multiple goes through the total value of the function a(xt). A is not multiplied in the t or time or inside the function, that is outside the function. If this kind of thing happens, then the value will be changed. How that will be changed? That is the sinusoidal signal you have seen here. If it is multiplied by 2, that means this value will be changed. The value of y-axis will be changed. Signal y is expanded or compressed in amplitude or reflected about horizontal axis. In previous rules or conditions, we change it by x-axis. Now we will change it by y-axis. Why? If it is 1, the value here, now if you take, that is 2xt, here we get we take 2xt, the multiply by 2, 2 into 1, 2, the value will be there, that is minus 2, that is minus 2, so the value will be larger, like this, same as. Again, if you take half of it, that will be compressed, 1 into half, so the value will be compressed like this. How that will be taken? If you take half of xt, how the compression acts? It is amplitude compression, okay, not x-axis. That will be in the y-axis. It is 1 into half means half, so the value will be just below to start from here. Again minus half, again plus half, very much it's compressed. Okay, if you take minus value, you take minus out of it, okay, how that it will be changed? It is minus 2, minus plus 2, the wave shape will be changed in that position. That is negative waveform, that will be a positive waveform. The positive waveforms will be the negative waveforms. That means that is 2xt minus 2xt. Minus means the waveforms will be changed. It is positive, that will be negative, just like this. Okay, now what is amplitude shifting? First of all, in time shifting we have seen t plus 2 plus b plus a. If you just plus or minus, this operation is outside the function xt plus b as a real number, so that will be an amplitude shifting. What is amplitude shifting? Now that is xt, x minus 2. Minus 2 means just shift the value here, that is 2. Okay, 2 minus 2 is equal to 0. So this point will go down to the 0. You can get it from 0. Think of it. In minus 2, that is a 0 position. So 0 minus 2 is equal to minus 2. That means the value will be shifted down to minus 2. Look at it. That goes down. If it is plus 2, that will go up. It's like this. That will be plus or minus, any kind of thing. That is known as amplitude shifting, up or down. Shift will be started from the y-axis. Amplitude means the y-axis, and you know another thing is the x-axis. That means time shifting. That is the thing that I have told you. Combination of the amplitude scaling and amplitude shifting, a combination of that. First you took this, then that, like this. Thank you very much for being with me in this large analysis of properties of signals. I hope you're better luck next time. Thank you very much for being with me.